The topic of today's practical class is simultaneous estimation. Simultaneous estimation of two components using UV visual spectrophotometer. UV visual spectrophotometer is a very convenient instrument, but it has got a limitation. Unlike HPLC, which can separate the mixtures into its individual components, a simple spectrophotometer cannot separate. It will give an absorbance, but that absorbance is the sum total of all the absorbances present in a solution. You know, the basic principle of absorption is that the absorption or absorbance depends upon the concentration. The more the quantity of a substance, more will be the absorbance. In a spectrophotometer, the main difficulty is that it gives you a total value of absorbance. There is no way of telling, looking at this value, that which component has absorbed how much. A big difficulty. But this difficulty can be overcome by applying a bit of mathematics. What you have to do? You have to develop some equations. If you have two component mixtures, there will be two equations. For a three component mixture, there will be three equations. And you have to solve these equations for common values of the components, which are actually symbolized as x1, x2, x3, like that. And these values will give you the concentration of each. Now, see what are the steps for these practicals. The very first thing is that you have to find out the absorption maxima by scanning. If we use ibuprofen and paracetamol, we have to get the absorption maxima for these drugs. Next, the most important thing is development of standard curve. We have taken two drugs, so there are two maximas. You have to develop standard curves for each drug at each maximas. That means 2 into 2. We'll get slope values from these equations of the standard curves. So once we get the equations, we'll develop equation for the standard curves. We'll use this for developing the equations for the mixtures. And finally, we have to measure the absorbance of the mixed solutions at both the wavelengths, since there are two drugs, two wavelengths, and use these values into that equations. You know, the classical equation of the standard curve is y is equal to mx plus c. Y is the value of absorbance which we get from the spectrophotometer, and m is the slope value. Now, m represents the value of absorbance, that is, the slope represents the value of absorbance when the concentration is 1 unit per ml. Now, unit is not always microgram per ml. It can be different. It can be milligram per ml. It can be nanogram per ml also. So that is not important. If the unit of concentration is microgram per ml, the slope will give the absorbance by 1 microgram per ml of that substance. I repeat, slope is the absorbance of 1 unit per ml. The unit is specified in the concentration axis of the standard curve. Now we are coming to the actual working part. The general equation for standard curve is y is equal to mx plus c. So let's assume m1 and m2 are the values of slopes for paracetamol and ibuprofen at the absorption maxima of paracetamol, which we have actually coded as P. M1 and M2 are the values of slopes for paracetamol and ibuprofen at the absorption maxima of P. So you have kept the absorption maxima, that is the wavelength, same, and since the drugs paracetamol and ibuprofen are different entities, their values will be different because they absorb differently that particular wavelength. So we have got two standard curves, each with different slopes. They are codenamed M1 and M2. Similarly, M3 and M4 be the slopes of paracetamol and ibuprofen at the absorption maxima of I. Sometimes a drug does not show proportional absorption, insignificant absorption at the second wavelength. That makes matter even easier because the value of M will be 0 at that point. Next, we have to take the mixture. The mixture will be prepared in the same way with the same medium, that is solvent, that we use for the standard curves, and measure the absorbance of the mixture at both the wavelengths, and this is coded as Y1 and Y2. We have taken paracetamol and ibuprofen, and in our actual experimentation we found that the lambda max, that is the peaks of paracetamol at 257, and for ibuprofen it is 224. Now M1 will be the slope of paracetamol at 257 and M2 is the slope of ibuprofen at 257. Something like that. Let's assume the concentration of paracetamol is C1 and concentration of ibuprofen is C2. Both the drugs absorb simultaneously. So whatever be the absorbance and whatever be the absorption maxima, the total value is recorded. Each drug has contributed to this value. Now, see the equation Y1. Let's take the mixture has shown a value of absorbance which we have taken Y1, which we have taken as Y1. Now, Y1 is equal to M1x1 plus C1 plus within the bracket M2x2 plus C2. Now, why did I put them into the bracket? I said both the drugs have absorbed and in the total absorbance both have contributions. The generalized equation for standard curve is y is equal to mx plus c. I have taken x1 is the concentration of paracetamol and m1 is the slope. Slope means the absorbance for unit value. So, m1 multiplied by x1, that is m1 x1 plus c1, which is the constant, is the contribution for paracetamol. Similarly, m2 x2 plus C2, which is placed within another bracket, is the contribution of ibuprofen. The total value Y1 recorded at 257, or the first, whatever be the wavelength, is equal to M1X1 plus C1 plus M2X2 plus C2. Contribution of paracetamol plus contribution of ibuprofen makes the overall value of absorbance at one wavelength. Similarly, Y2 is equal to M3X1 plus C3 and M4X4 plus C4. See, everything is almost same, the pattern is same, only the slopes are different. That's why we had to use different symbols. We did not change one thing, that is the concentrations of the two factors. Now, we'll be getting numerical values for this M1, M2, M3, M4, Y1, Y2, which is looking so difficult with the symbols, will be much more simplified once you get the numerical values. There will be only two unknowns, X1 and X2. And two equations with two unknowns. There is standard methods for solving them. Since the concentrations are same, only the wavelengths at which they are measured, the equations developed will have to have a common value. We have to look for the common value of X1 and X2 that satisfies both the equations. So, there are standard methods. Normally we multiply one equation with a number so that one of the components becomes same, and then we cancel that. Okay, but the video is getting too long. I cannot give the demonstration here. For that, you have to see the next video. The final thing is that X1 and X2 we have actually coded as the concentration of paracetamol and ibuprofen. If you get X1 and X2, you have already got the concentration present in the mixture. And if there were dilution factors, that is, if you have diluted before you took the readings, these values need to be multiplied with the dilution factor. Hope I am clear. Thank you.